The key concept I've decided to explore comes from the topic of forces of nature in the universe. From the topic, I've pulled out the force of gravity as my key concept I wish to discuss. I'll be specifically exploring this concept in the Physics 20 curriculum, covered in Unit B, Dynamics. The force of gravity is regarded in the Program of Studies of Alberta Education as one of the fundamental forces of nature. The idea of gravity first originated, as the story is told today, when Isaac Newton had an apple fall out of a tree onto his head. This seems rather silly, but the aftermath of this event and the conclusion that Newton came to was absolute genius. The force of gravity is everywhere on Earth and even in outer space. Every object in the universe with a mass is subject to and exerts a gravitational force. This speaks for the significance of the force of gravity. Every time we jump, it's the force of gravity that brings us back down. Every time an object falls, it's because of the force of gravity. The sub-concepts or related concepts for the force of gravity are force in general, Earth's acceleration due to gravity constant, 9.81 meters per second squared, the force of gravity formula, F equals mg, Newton's laws, and there are many more. The force of gravity is a very broad and overarching concept in physics. There are many ways a teacher can find students' prior knowledge on the force of gravity, both before the students enter the classroom and with the students. First, before the students enter the classroom, the teacher can consult the Program of Studies for Physics 20. In the overview section for Unit B Dynamics, there is a section that says, "This unit builds on." Then there's a short list of past years that relate to this unit. Then what a teacher can do is consult those past programs of studies that the list shows. Though this is a good strategy, it can often be inconsistent, since not all teachers teach exactly what is in the program of studies or the same way. This is more of a good guide to know what your students are supposed to know. I believe that the best way to know what previous knowledge your students possess is to do something with them in the classroom, and there are multiple ways of doing this. One strategy is to have a brainstorm with the class on everything they know about gravity, while you write down on the board what they say. Another strategy is to have the brainstorm activity as individuals, pairs, or even better, groups of 5 or so students. If I choose a group, I could also have them present to the class. Lastly, I could make up a short formative pre-test on gravity. Some common misconceptions. The first, as stated by the Lunar and Planetary Institute of the United States, some common misconceptions that students make about gravity is that the moon has no gravity. That's probably the most common one. Planets with thin atmospheres have little gravity. Planets distant from the sun have less gravity. And space shuttle astronauts are weightless because there is no gravity above Earth. Now, from Prezi.com, some more common student misconceptions about gravity are: gravity does not affect objects in water. Gravity underwater will make you drown if you are not swimming. Objects float because they are weightless. There is no gravitational force acting on an object that is free falling. Finally, from the UK Institute of Physics, another extremely common misconception: heavier objects fall faster than light ones because they're heavier. Now, in teaching the concept of forces of gravity, the first thing a teacher should do is to attempt to eliminate those misconceptions. Most of these misconceptions can be eliminated through the strategies discussed in Part B. Part B will allow the students to vocalize their misconceptions before the lesson starts, which will then allow the teacher to be aware of and eliminate them. Next, if I were to teach this concept, I would try to use the portion that is the most interesting to students. I believe that this would be anything to do with outer space. Obviously, this isn't always an option, especially when discussing gravity on Earth. One activity from the SSERC website says to use a Newton balance and get the students to weigh different objects and record their weight. As an adapted version, I thought they could use their answers along with the acceleration of gravity constant to find the mass of the object, if it's not specified, then use that mass with a provided value for the acceleration due to gravity on the moon. Find the object weights on the moon and compare that value to the value for Earth.